We're now going to continue with our Excel lesson. In this lesson, we're going to take a look at creating frequency tables, sorting data, charts, histograms, and scatter plots. Now let's start with creating a simple chart first. So in the second sheet I have over here, we have our monthly expenses for a household for its heating expenses. So you notice in October this house spent $120 in heating expenses, November $230, December $354, and so on. Now remember, if you want to create these months over here, you can just type in October, grab the fill handle, and drag down, and Excel will create those months for you automatically. Nice feature there. So now we want to create a chart that illustrates these heating expenses graphically. So do this. Highlight all of the cells like that just by using the mouse, clicking in the center of October and then dragging downward like that. Highlight all of them. And then go up to Insert right up here. And we're going to insert a chart like this. And we're going to do a 2D chart. So right there we go. Alright. Pretty simple. So we've just created a chart illustrating the monthly heating expenses. Notice that you can see how your expenses, how they increased and then decreased, which is natural. You have your months down here. The height of each column represents your monthly expense. So if I put the cursor over top of that one, you see the value. The height is 120, 230, 354, and so on. Now, let's play with this chart a little bit, just modify it a little bit. Notice that if I click on a cell outside of the chart and then click on the chart, notice how up here in your Design tab, you have Chart Tools appear. These tabs contain formatting commands for this chart that we can use. Now let's see. First of all, let's adjust the months down here. They're sort of crammed together down on this axis. I'll show you a trick here. Right click on that and click on Format Axis. So we right clicked on like one of the months, right clicked, and then click Format Axis. So you should see this box over here pop up, and then click on Text Options over here. And then click on that little text box icon right there. Then go down to Custom Angle. And we're going to just do this. We're going to decrease that angle. And so that's nice. So it looks a little bit better like that when they're angled like that. So a little trick there you can do. You can also change the chart title just up by double clicking on it and changing it to heating expenses like that. We can add labels to the y-axis if we want. Click on the chart and then click on over here, you see Add a Chart Element. Click on that and we're going to click on Axis Title. So let's click on Primary Vertical, Axis Title, Primary Vertical right there. And then we can go in here and change the title of representing. So we would just type in here expenses or dollars. There we go. And then we can move that around if we want just by grabbing it and moving it a little bit. You can also change the formatting if you'd like. Sometimes it's a little tough to grab it because there we go. And then maybe increase the font size a little bit and so on. You can also increase the chart size like that. And there you go. Alright. Let's change the gap width of these columns. So if we right click on one of the columns and go down and do Format Data Series, you see a gap width appear over here. So let's just reduce that gap width down to about, maybe 10 or 20%. There we go. That looks a little bit better. You can also do fancy things like add fill coloring to these bars. I'll let you play with that over here. You see you have fill colors. You can add borders to them and so on. All types of fancy things you can do with these bars, but we're not going to really need that right now. Alright, so that's the elements of creating a chart. Let's see, what else could we do with this chart? Oh, we could add a month down here, a label for the x-axis. That would be up here. If we click on the chart, you see your chart tools comes up, add a chart element, primary horizontal, and then we could just put months down there. Hard to grab that sometimes. There we go. Months. Make that a little bit larger. And there we go. Alright. So that's a nice little chart. That's called a histogram that illustrates our monthly heating expenses. And let's also do this. Let's put in the sum of all of our heating expenses and the average monthly expense. So down here we'll put a total and the average. And we'll make them bold. So for the total, we'll do an auto sum, or we could type in equals sum by hand. There we go, that's nice. So, oh, that's interesting, exactly $2,222. And our average would be then equals, I'll just type in average, I know what it is. I know the name of the function. And then just highlight, close the parenthesis off, and hit enter. And there's our average monthly expense, $277.75. We could also put in a standard deviation. Standard deviation. Now, if you forget what that is, you can go up here and click on the function, insert function, and look for standard deviation. If it's not under most recently used, it would be under statistical. So we'll just do most recently used, STDEVS, there it is, since we just used it a little while ago. And then highlight the data that you want. You don't have to click on that red button, but you could. Red button right there. And then just click OK. And that's our standard deviation. Now let's take a look at creating a frequency table. So for this one, we're going to use the bare weight data set that's posted on Moodle. So if you would, open up that data set and it will look something like this. Okay, so you'll see this is our data set. So if you open that up on Moodle, you'll see a spreadsheet that looks just like this. Now what this represents, each row represents one bear that was captured and measured. So this bear right here had an age of 19 months estimated. It was the month it was captured, male or female. The head length, let me make that column a little wider. The head width, neck circumference, overall length of the bear, the chest circumference, and the weight of the bear. Now what we're going to do is we're going to create a frequency table that summarizes the weights of each bear. You see, it's sort of hard for someone to look down all these data values here. There are 54 of them in total, and have an idea for, what the distribution of bear weights looks like. And so we're going to create a frequency table to summarize that. Now before we do that, let's do this. Let's practice using our Excel formulas. Let's create an average and a sum, average, and standard deviation. So let's do this. We're going to do, let's actually insert a column right here. So I'm going to insert column, and then we'll do this here. We're going to do sum, or we'll just do this. We'll just do average and standard deviation. All right. So this is the weight column right here. So we're just going to put in equals average. Remember, if you forget the word average, you can click on the function and go under statistical. I'll do that for the standard deviation to show you that. And then I put a parenthesis in there, and then I'm just going to highlight all of this data right here. There we go. Close the parenthesis off, hit enter. Okay, so the average bear weight was 182.9 pounds, approximately. Standard deviation, if you forget what that is, go up and click on the f of x. And then that would be under either most recently used or statistical. If it's not under most recently used, look under statistical, go down to STDEV, right here it is, STDEV.S, that's the sample standard deviation. Click on OK. It asks you for what values. Just click on that little red button, and then we'll highlight all of our weight data. And then hit enter. And click OK. And that's the standard deviation. Now what we're going to do is, moving back up here, we are going to count how many bears are in these classes that we have set up here. So we're going to count how many bears had a weight between 0 and 49. That's going to be this class's frequency. How many bears had a weight between 50 and 99, 100 and 149, and so on down to 500 to 549. Now the bear with the lowest weight had a weight of 26, so that'll go in this class. That's why we start from 0 to 49. The bear with the largest weight had a weight of 514, so that'll go in this class. That's why we went up to 500 to 549. And the way you determine how many classes you want and what your lower and upper class limits should be, that you'll talk about more in your statistics course. Now, so we're going to recreate this up here so I can show you how to do it. So we're going to put our classes here. Let's just recreate it up here. So follow along. We're going to have our lower limits of each class, our upper limits, our frequency, and then we'll do some relative and cumulative frequencies as well. Now, the lower class limits are the lower numbers in each of these classes, so they're going from 0 to 50, so just go 0, 50, and then you can just highlight them, grab your fill handle, and drag down to 500. The upper limits of each class we're going to put right here, so 49 to 99. Highlight those, or grab the fill handle, drag down, and there we go. Now, for the frequencies, you could sort this data and count by hand how many bears had a weight between 0 and 49 and put that number right here. And the same thing for all the other classes. We're going to have Excel do it for us. Now this is a little tricky, so watch. What we're going to do is highlight all of the cells aside of our upper class limits like that. Now we're going to insert a frequency table. So click on the function, the insert function, f of x right there. And now we're going to insert a frequency table, so we have to look for the word frequency here. Now if you don't see it, it would be under statistical, right there, and then click OK. Now, it's asking us for the data array and the bin array. The data array is going to be our data, so we can highlight, put the cursor, make sure the cursor's in the data array, or click on the little red arrow there, and we'll highlight all of our data. So just highlight all the weights going down to 55, and then put your cursor in the bin array, or click the little red button there. Now our bin array, I have to move this, our bin array are going to be all of the upper values here. highlight all those. Now do not click OK. Do not click OK right now. If you accidentally clicked OK, you'll have to go back in the video and start over. Okay? What you're going to have to do now is hit Control, Shift, and Enter. That actually inserts a frequency table, an entire table of frequencies here. If you just clicked OK, it would insert only one frequency right in cell O, that would be O3 right there. So now, once again, once you have these two, it should be like this, J2 to J55, N2 to N12. Now hit Control, Shift, and you hold the Control Shift down, and then hit Enter. There are the frequencies right there. Okay, so that's how many bears had weights between 0 and 49, 6 bears, 50 to 99 were 10 bears, and so on. Now let's create a histogram that demonstrates or shows us graphically how the weights are distributed. So what we're going to do is, let's highlight these values and then click on Insert and a 2D column. And here are the bear weights. Now we're going to have to clean this chart up a little bit right here. So we had, you notice in this class right here, 0 to 49, we have 6 bears. Notice the 6 right there. In this class, 50 to 99, we had 10 bears, sorry, not 100, 10 bears, and so on. Now, it would be nice instead of the numbers 1, 2, 3 through 11 down here if we could put these class values here like the class descriptors 0 through 49, 50 through 99. So I'll show you how to recreate these numbers right up here. So type in this. My lower class limit is in cell M2, so we're going to do this. Watch. Equals M2 and now we're going to put in this text string, so quotation marks, space, dash, space, quotation mark, and N2. And then just hit enter. And there we go. Now what we can do once again, if you want to look at that, put a space in there so you can read it a little better. It was M2, the and symbol, quotation marks, a dash, end quotation marks, and N2. And that'll create the, hit enter, 0 to 49, and then just grab the fill handle and drag down. And there you go. Of course, instead of grabbing the fill handle, if you wanted to, you could go Control C and just copy down like that. Now, what we're going to do is we're going to replace the 1 through 11 with these values right here. So, click on your chart, and let's go up here to the chart tools up here. We're going to click on Design and select Data. Okay, so we're going to click on Design and select Data. Now click on, you see the horizontal axis labels. We're going to edit those. Click on Edit, and then make sure your cursor is in here, or click on the little red arrow there, and then just select all of these values. And then click OK, and click OK again. And there, now you see the class descriptors are down there. Now we can format them, so we'll right-click on Format Axes, and then we can go over here and click on Text Options, that little text box right there, and Custom Angle. We can angle them so they look a little nicer. And there we go. Now we can change the gap width here, so just click on those, right-click. Let's see, we'll just do, let me do that again for you. Right-click on one of the bars. Right-click on one of the bars, and then format data series, and then just change the gap width. We're going to make it about 10, somewhere around 10 will work fine. Okay, now that looks a little bit better. And so you see now we can read off this chart. We have 6 bears with weights between 0 and 49, 10 bears with weights between 50 and 99, 10 bears with weights between 100 and 149, and so on. So this gives us a nice visual description of our bear weights. Notice that we have a large group of bears that are actually fairly small. And then we have some larger bears out here, but notice how the distribution has sort of a tail off to the right. And so we would say that this distribution is skewed to the right because our tail extends off to the right. So we have a few bears that are really big, probably older bears, but most of this population is fairly young and fairly small. All right. And of course we could change our chart title here. Bear weights. And we could add some axis labels. And let's see, where did that go? Lost my axis label. Oh, I see what I did. I accidentally, okay, be careful here. I accidentally removed my vertical axes by selecting axes, primary vertical. This either removes or puts them, it will remove them. So I don't want to do that. I wanted to go to axis titles right there. So there's my vertical one, and then I could just put the weights right here. Or this would be, sorry, that would be more like the frequency right there. The number of bears, that's what that axis represents, the number of bears. Okay. All right. And then down here, this one would be the weights. And then we would just have to move this up a little bit. There we go. A little bigger. Move that down. There we go. Sometimes it's hard to get the boundaries of these things, to grab those boundaries to move it around. All right. There we go. That's a rather nice histogram representing the bear weights. And like I said in another video, you can do this in using Megastat. Problem with Megastat is it only gives you the relative frequencies over here, which we'll look at now. So doing it by hand like this, gives you a little more freedom of choice in how you want to arrange your data. So let's take a look now at relative frequencies. So a relative frequency tells us the percent of all bears that have weights between 0 and 49. Now in this data set here, let's add up how many bears we have. Well, we know we have 54 bears, right? So, but we could just double check that. Equals sum. That would be O2, or we can just highlight with our mouse, using our mouse there. Okay, so we have 54 bears. Now what we're going to do up here in the relative frequency is we're going to put the percent of bears that have weights between 0 and 49. So we're going to do this, watch. Equals O2 divided by, now we could do this, $, O, $. Let's see, that 54 is in row 13. And then times 100. And, oops, I have an error in my formula. Let me see, what did I do wrong here? Oops, I put the number 0 instead of O. Change that. Okay, unfortunately the O and 0 on the keyboards are right above each other, aren't they? Okay. There we go. and then drag down. And there we go. There are the percents. Now we could format each of these. We could round, format the cells so that they are we only display 2 decimal places. There we go. All right. Now the total here should be 100%, right? If we did sum P2, just do it like this. Okay, yep, 100%. Okay, now let's create a relative frequency histogram. Now, to get these classes down here, I'll show you a little trick. Highlight your classes, then hold the control button down and highlight your frequencies, your relative frequencies. Now, insert a chart, and notice it automatically put the 0 to 49 down here for us. We didn't have to go and do that manually. All right? And so, now here we go. We can do the same thing we did before. We can adjust the x-axis labels like this. Then we can adjust the gap width. Format data, once again, right click on one of the columns, format data series. Change the gap width to 10 or so. And there we go. Now you notice one thing. The relative frequency looks just like the regular frequency histogram. And that is always going to be the case. Because all you're doing with these column heights over here is you're just dividing by 54 and then multiplying by 100. So you're just multiplying the height by a constant, and that will not change the scaling or the relative size that one column is in relation to another. So the relative frequency looks exactly the same. But notice now the way you read off the heights of each column gives you the percent. So for example, 0 to 49, we have about 11% of all the bears had weights between 0 and 49. 18.5% of all the bears had weights between 50 and 99, and so on. All right, and that is a relative frequency histogram, so we could change our title to Bear Weight Relative Frequency. And there we go. All right. And the font there's a little small. I might make that a little bit bigger. A little too big there, but there we go. Have to increase the size then to see everything. Okay, so there's the Bear Weight Relative Frequency histogram. You could also increase the font size down here. And there you go. All right. Now, if you wanted to create a cumulative frequency distribution, what the cumulative frequency is going to be, it's going to be the sum of all your frequencies as you go down your classes. So watch what I do here. I'm going to put my first frequency right there, 6. Then watch what we do. Follow along. Equals Q2, this is column Q, plus, and we're going to go plus O3. Oops, O3. All right, 16. Now notice what that 16 is that is 6 plus 10 gives us 16. So this tells us the cumulative frequency, or all the bears that have weights of 100 or less. And then all we have to do is drag that down. And you notice we go from 6 all the way up to 54. So this tells us, for example, that 43 tells us that 43 bears had weights less than 299 pounds. 41 bears had weights less than 249 pounds, and so on. So that's our cumulative frequency. Now, well, let me show you one other thing here. If you wanted, on our relative frequency histogram, if you wanted the percents to show up here, I'll show you a nice way to do that. Go back to our relative frequency column here. I'm going to hit F2 and change something. I'm going to remove all of, just watch what I do. I'm going to remove the 100s. So now instead of 11%, we have 0.11. I'm going to copy that down. Okay. So you see all these change. They're all, instead of percents, 100, out of 100%, they're all divided by 100 now. And notice our sum is 1. Now what we can do is you can actually format those cells to represent percents. Watch this. So right-click, highlight them, right-click, format cells, percentage, and then click OK. And there you go. Now they're all percents, like that. See the nice little percent symbols there. So you can see then, about 18.5% of the bears had weights between 50 and 99, and so on. Okay, so that's how you can use cell formatting also to get those percents. Now let's take a look at creating a scatter plot. So let's see. Let me move these charts out of the way. Now we're going to create a scatter plot. Now to create a scatter plot, here's what we're going to do and what data we're going to use. Let me first just click somewhere in there to get rid of the purple and blue highlighting. We're going to create a scatter plot of the chest size of the bears versus their weights. Now follow along, I'll show you what I mean by that. Highlight the chest and weight data like this. And then just go down, highlight that data. Now click on Insert, and there's an icon over here that we want. Right here we want this first one right there, a scatter plot. So click on that. Now we come up with this chart that looks like this. Now what this represents is what we call a scatter plot. Now let me, I'm going to have to draw on here to illustrate something. Now for a scatter plot, you notice the first bear here had a chest size of 26 and a weight of 80. So if we plot the point 26, 80 on the Cartesian plane, which is what we have right here, that point 2680 might be, well, it looks like it might be that one right there. So we would plot that point on the Cartesian plane. Then this other bear here had a chest size of 45 and a weight of 344. So then we would plot 45, 344 on the Cartesian plane as well, and that might be right about, let's see, that one is probably this, could be this, probably this data value right there. Okay, plotted out. And then we do that to all of these. So Excel has done this automatically for us. So you see all these little dots represent the coordinates of one bear, their chest size versus their weight. Chest size is the X coordinate, weight would be the Y coordinate. So each dot represents one bear. Now what this does for us, doing a scatter plot like this, is it gives us an idea of the relationship between the chest and the weight of the bear. Notice that these dots all follow a nice linear type of progression upward. That tells us that there is a strong correlation between the chest size of a bear and its weight. You notice how they're all centered around a common line here. Now, if they were scattered all over the place like this, we had points all over like this, then we would say there is not a strong correlation between the chest size of a bear and its weight. Now, naturally, there should be a relationship between the chest size of a bear and its weight. The more a bear weighs, the bigger its chest is going to be, or vice versa. The bigger its chest, the more it's going to weigh. So, of course, there is this natural relationship. But it's for other data sets, it's not always going to be obvious if there is a relationship or not. And so that's what a scatter plot does for us. Now, what else we can do with this is we can actually find what is called a trend line. And by the way, we could also clean this chart up. We could add axes labels and chart titles to it, just like our other ones. But let's look at adding a trend line. So what we want to do here now, just right-click somewhere on one of the data values. Okay, right-click on one of those data values. Just pick one and right-click on it. And you see right there the option Add Trend Line. Click on that. Now over here, we have some options. We want to select a linear trend line. So click on linear. We have other options. We could do polynomial, exponential, and so on. We're just going to do a simple one, a linear one. You see a little dotted linear line appears there. And then we're going to click Display the equation on the chart and display the R² value on the chart. Alright, we'll talk about that in a second. So let's move those over here. And then we'll click on, well, we don't have to click on anything, we're okay. Then we'll just click on the chart somewhere. Alright. Now, let's see, let's make that a little bit bigger so everybody can see it. Let's see if I can get that and format that font. Let's make that a little bigger. Okay, so there. Now, what this is, this line right here, this is the equation of the best fitting line. So y equals 12.5x minus 264.48. That is the equation of this dotted line right here. That is called our best fitting linear trend line. So that's what Excel found for us. This is the best fitting line. It fits the data the best. The R² value, that's going to be a number between 0 and 1. The closer it is to 1, the stronger your correlation. So notice this number is fairly close to 1, 0.9.93 approximately. And our data values fit around that line pretty tightly. So that tells us that, this number being close to 1 tells us that we have a pretty strong correlation here. Now we can use that trend line to predict what a bear that had a chest size of 60 would weigh. And the way we would do that is we would just put 60 in here for that X. So if we look at Y of 60, and we put 60 in for the X, times 60, and we solve that, we get, evaluating that, we get 488.16. And so that would be somewhere, that would be if we continued this trend line upward, that 488 would be right about there. All right, and so that's how we find a scatter plot for a data set. All right, so that concludes this lesson on using Excel to create charts and scatter plots and frequency tables.